Do you want to start with me? Next up is Gareth, who's going to talk to you about Pi2Go.
Hi there, I'm Gareth. I don't exist according to Twitter, so I thought I'd start by putting a hologram helmet on with NeoPixels with an H on it. But unfortunately I'd have to use an Arduino, and as it's a Raspberry Jam I thought that would probably be against the principles of the thing. Anyone who's been interested in Pi2Go I think's probably popped along to see the stand, so I'm going to focus a little bit more than I would normally about the development process. How did I get to the product that we have now for sale? So I wanted to build a product for a classroom. My roots are in education. I've worked in education for God knows how many years. And I wanted something that you could put together in a classroom in less than 20 minutes or something like that. Could actually get running very quickly thereafter. And you can write in Scratch or Scratch GPIO extensions, and you can write in Python and so on. I wanted it so that the Raspberry Pi could be plugged in and taken out. So if in a primary school, for instance, they didn't have a lot of Raspberry Pis, they could use it in many different ways. So just use it in a case, take it out of the case, plug it into the Pi2Go, and away you've got a robot that you can use. I wanted all the sensors to be ready and available for them, so that once they put it all together and they can see how it all goes together, so the students know what they're putting together, but they don't have to do the soldering. They've got all the sensors there, so I wanted to have the right number there. I find robots that are just driven by keyboard commands to be slightly problematical, really. In my view, a robot has to have some intelligence, has to use that intelligence to direct what it does. Whether that's just move around a class, avoiding obstacles, following a line, or doing something more complicated is irrelevant. The basic thing is it has to be autonomous and not driven by the human. The human can tell it what to do, but then it must go off and do it on its own. So it needs those sensors, it needs those output devices. And along with many of the other things that I've done at Fortronics, I wanted it to run off a single battery pack, so I didn't want to have a battery pack for the Pi and a battery pack for the motors. I wanted just a single battery pack to cover all of it. So that was my basic starting point. And before I actually went on to produce anything electronic, I built this. And this is a really high-tech robot. It's got 2 DC motors and wheels, and it has a piece of cardboard. But what that proved to me is that you could actually make something of that size that actually did the job. It's got the necessary mounting holes in here, so I could actually mount the Pi on it. I could see how it fitted. I could see where I could put the batteries and things like that. You can see this one's got a little cable tie. That was originally intended to have one of those little USB little USB battery sticks that would sit in there underneath the system, but unfortunately that just didn't have the power. I needed 2 of the lithium batteries that are inside those things to power it, and then there was just no room. Unless we produced one that was slightly wider. So this one underneath has a position for 2 18650, which are the lithium batteries that you see in those little USB power packs. Now that one would work in a much neater way. The Pi would sit directly on the top. You wouldn't have any batteries in the way of taking the Pi out, but you get the disadvantage that the whole thing becomes wider, it's harder to maneuver, and in the end discussed it with many others, and we came to the conclusion not to use that form factor, but to use that form factor. So I went through a number of PCBs, and this was the final solution of me making prototype PCBs. All the sensors that are on here are the ones that appear on the final product, and I'll go through what they are in a second. So basically this hand-built prototype is the forerunner of the Pi2Go that we are about to start shipping. So sensors, what are there? So in terms of input sensors, we've got an ultrasonic sensor, so you can measure the distance, how far away it is from an object. On the bottom it's got two IR sensors which are used for following lines, so if you've got a line you can track it quite easily. It's got two infrared obstacle sensors there, so it can actually recognise coming up to obstacles independently of the ultrasonics. And furthermore, it's got a single IR one at the front as well, so without using the ultrasonic you can still get a distance sensor. So with the ultrasonic you'll find that when you get too very close it starts losing its ability to judge exactly how close it is. So with this particular sensor on the front as well, you can go really close to a wall and stop without actually hitting it, which might be of some use to Pi wars, I'm not entirely sure. We've got a regulator on the board. This one is a linear regulator and it gets reasonably hot. I'd like to use the word warm, but actually it gets quite hot. For the final product we've gone with switching regulators throughout the range, and that's made it all a lot cooler and it runs really well. You can see on here there's a blue board. This is the Adafruit PWM controller board. It's actually probably my favourite Adafruit board because it's really, really easy to use. It's an I2C interface and it outputs 16 PWM channels, which I'm using to drive the RGB LEDs that are on this device. There are 4 channels left over after having driven that, and I'm using those to drive 4 servos. So you can have 4 servos on that as well as the 12 RGB, 8 RGB LEDs. What haven't I measured? Covered. I think that's it for sensors and inputs and outputs. Right, so next thing, I wanted to make this product as a product that you got out of the box, screwed together and started using. That meant it had to be pre-soldered and it had to be ready-made essentially and fully tested, and because it is such a product it has to be fully CE tested as well. So I'm using a manufacturer I've used in China for many years. I've actually got 3 really good manufacturers that I use out there for various projects. One of them I used for the Initio, which is our 4-wheel drive product. One I'm not using yet, and the third one I'm using to develop this. The reason I'm using these people for this one is because they're also the people who manufacture our Pi2Go controller board for us. So because there's a lot of things in common, it makes sense for the same people to do that for us. So I chose the manufacturer, worked out a payment method with them, and because I know them so well I got a really good agreement, which is they ship me the product and sometime later I pay. You don't get that from China very often, as I'm sure Jim will be telling you later on. Right. At this point, I forked the project. I think that's the right word. We decided that there are a lot of people who are interested in it from a geeky point of view, from a hobbyist point of view, who didn't want to be paying the extra for someone else to build it for them. They were quite happy to do the soldering. But that meant that we couldn't actually add in all the features that we want. So I came up with a reduced feature set, used through-hole components throughout, so it makes it solderable by intermediate level. So I wouldn't use it as a beginner level soldering, definitely wouldn't, but as an intermediate level, I think it's appropriate. Michael's about to find out when he starts soldering his up in a few days' time, hopefully. It's essentially the same design, so this one here is the Pi2Go Lite, and wherever it's gone, and this is the early version of the full Pi2Go. There is a difference in colour, and that's part of the difference. So yellow is the Pi2Go Lite, which you have to solder yourself. The red is the full Pi2Go. Obviously this one's a lot cheaper, so we're selling this at £35.95 plus VAT, whereas the full Pi2Go is £60 plus VAT. Because this one isn't going through the full CE certification process, it's actually now available today. So we're selling these starting at the CamJam, and they will be online as of tomorrow or Monday for sale. So there you can see the full specification of the two products. I'll go back to that in a bit. But one of the things I should have mentioned earlier is that one of the differences is that the IR sensors on here are raw, in that they go straight back to the Pi, and the Pi has to monitor the individual signals and check that it's all sensible. On here, they're pre-processed by a separate processor that runs on here. This separate processor monitors the power supply, tells the power supply tells the Pi if the power supply is getting too low, so the Raspberry Pi can shut off. And it also switches off the motors if the battery is getting quite low as well, so that it doesn't get the big, huge power surges that would kill the Pi when it's getting low. So it's got quite a lot of extra circuitry on that. It also has a bit of anti-glare technology, so it pulses the light sensors instead of just solid reads. Must move on quickly. A couple of add-on products to show you. One is the pan tilt system. So that's available now. So that allows you to put the Pi camera on the front of this with a mounting plate that sits on the front of that. I've got the mount on the table. I didn't bring everything in. But you can see behind me the three options. You can either mount the camera directly on it, so you just have a camera mount, or you can have it on a single servo, so you can pan it either way, or you can have pan and tilt as well. So that's available now. Pimp my bot. I'm not sure I can say that in polite company, but these chrome wheels, these yellow wheels are pretty naff. You know, they're common as muck. Everybody can buy them, and they're really cheap. But these chrome-looking wheels really do look nice. They're actually built to a better specification, so they're more accurate in terms of their diameter as well. But they're about 10 times the price. They're a ridiculous price. So I'm selling them today at £5. Normally they're about £8 for a pair. And one thing you'll see on the table out there is I've attached a Mi arm from Phenoptics to it. This won't work with the Pi2Go Lite because this has only got 2 servo outputs, whereas the full one has got 4 servo outputs. So you need 4 servos for the Mi arm. And finally, the thing that we're releasing today is wheel sensors. So this is an extra add-on kit. It's not part of the original kit. Inside each of the wheels is an encoder disc, which has got 16 edges, so you can trigger 16 edges, and which means you know exactly where your wheel is at all points. And there's a sensor on the back each side as well. So again, you have to add that on. But this gives you the ability to tell you how far the robot has moved on each wheel. So if you want to go, say for instance you wanted to do a 3-point turn, which I've heard is something to do with Pi wheels, is that right? You would turn back one wheel faster than the other until the difference in the diameter of the curve between the 2 wheels, which equates to almost exactly 7 pulses, has been obtained. Once you've got those 7 pulses different between the wheels, you've done 90 degrees. And then you just move forward and then you do another 90 degrees, and hey presto, you've done a 3-point turn. How lucky is that? Yeah? And that's it. Thank you. Any quick questions before I get the red card? I'm sorry, you'll have to talk on. I'm shipping, no, I'm not shipping the Pi2Go. The Pi2Go is going to be about 6 weeks, I'm guessing, at the moment. The light version, where you have to solder it yourself, is available now. You might have to interpret for me.
Sorry, can you speak really louder?
What software?
You're right, I forgot to cover the software. Yes. So we have a Python library module that's available now, which works with both versions of the product. So you can control the motors at any speed, you can define the lights, they've got different lights available, you can check the wheel sensors, you can check your ultrasonics and your line followers. That's all available in the library in Python, so that's very easy to use. Simon Walters has created a version of Scratch GPIO that supports it. That's currently a dev version, so Scratch GPIO version 6 development is the one that covers that. So they're both available, and obviously with various examples that do different things. Okay, thank you.